All right, let's go ahead and take a look at number 9, types. So, in real life, using the right kind of object is important. Let's see, if you're going to play tennis, you want a ball, but not an egg. Of course, if you're going to cook an omelet, you don't want to cook with tennis balls. It wouldn't taste very good. So different types of things have different properties and behaviors. Programming is very similar. So we've already used something called a string, which works with characters and text. And so strings have properties and behaviors that are unique to that type. Let's go to the next screen. So in Swift, every value has a type. So we've already talked about types. We have strings, we've used numbers. And notice they behave differently. So for example, 1 plus 1 equals 2, but the string 1 and this plus string 1 equals 11 because it thinks of it as two strings. So as we've seen, this is called a string type. And a number is referred to as an int, which is an abbreviation of integer. So an int is a whole number with no fractions. So it can be positive, negative, or 0. But it's always going to be a whole number when you talk about an int. Now there are a lot more types in Swift. Just like there's lots of different tools, each tool is good for certain things, and it's not always, you don't use the same tool for everything. So even in Swift, we have different types. So let's learn more. Now, think about your favorite shirt. Okay, when you think about your shirt, it's probably not a banana. That doesn't make sense. A banana is not a shirt, at least not the one I tried the other day. So when if someone says, think about your favorite fruit, well, then it's certainly going to be some kind of fruit. The reason we are talking this way is because we kind of have a sense of what they mean when someone says this is a type, this is a fruit, or this is a shirt, or this is a type of an object. Well, in a way, Swift keeps track of the type with constants and variables to make sure you don't accidentally make a banana when it's supposed to be a shirt. So let's talk about types and variables. When you assign a value to a variable, the variable's type becomes that type of value. So, for example, we create this variable and we assign it a string. That means favorite thing is a type of string. So let's see what happens if we try to assign it something else, and we get an error. It says cannot assign value of type int to type string. So as you can see, it's important to keep track of the type. So now it says update the line above so that the variable can be updated. So how would you write it as string instead of an int? Well, if we wanted to use number 42 as a string, we would put quotes around it, right? And now it works. Okay, let's look at type safety. So you notice that when we assign the wrong type of value, it caused an error. So Swift won't let you write code that uses types incorrectly or unexpectedly. This is called type safety. So another instance of type safety would occur if you tried to add values of different types. So for example, if I uncomment this and I have a string banana plus a number, an int 1, it's going to throw an error because they're two different types and they can't be, it says binary operator cannot be applied to type string and int. So type safety applies to when you try to combine things or when you try to assign a different value to it. Let's see, it says operands are things the operator works with, such as a banana string or the integer of type. This says on the left or right there's a string and an int, and it doesn't know how to add them. How would you add them? That's interesting. All right, write some more incorrect addition statements. Before you write each line, try to guess what errors will be produced. Remember to comment out the lines of code from the earlier experiment first. Okay, so let's go with let some string equal what time is it, and then let some int equal 10. So let some message equal some string plus some int. Can you see what's going to happen? Well, it's going to throw a fit. Notice down here it says execution failed, type safety error, binary cannot be applied to operands of type string and int. See, it saw this and it's like, nope. All right, let's make this a string, and there it is. All right, let's check out types and literals. So when you write this value, like 42 or hello, it's known as a literal. And Swift makes an assumption about what type the literals are meant to be. So what that means is when you have a variable or a constant and you say this equals that, based on the type of whatever the value is, that becomes the value of the constant. Now, there's another common type that can be inferred. So we know whole numbers are ints, but there's a type of number with a decimal point. It'll be inferred as a double. So a double is called a double precision floating point. A float is another type, refers to a number with a decimal point, but the default double is twice as precise. Ooh. Now, notice it says part number equals 3.2, whole number equals 2. So try to perform a calculation. All right, let's see what happens when we try to combine something and we say part number plus whole number, and it's going to throw an error. It can't be applied to type double and int. See, it didn't like it. Now let's change this. Let's change it. Let's delete that. And now the type inference, it infers that now this is a whole number. And see how they add up properly? I can do the same here if I go back to like the double, and then I can do this and I can say that, and now check it out. Now they're both doubles. Very good. So that's called type safety. So let's take another look. Type inference from assignment. So literals are not the only way to create new constants or variables. An assignment has a left side and a right side. So the thing being assigned to and the value that's being assigned. So the value on the right will have a type and the left side will be inferred to have the same type. So I mentioned that already. So here you have a string and it's a type string. And even here, this type, because string is a type. Now, it says check the type by holding down the option key while clicking the another string key. So notice when I press the option key, my cursor turns to a question mark, and then I click on that, and it says it's a string. And the same here. It's a string. See this type? That is a string. Awesome. Now if we change it, let's change this to an int. Then what do you think the type will be of another string? What do you think? Let's check it out. It's an int, right? Because this value is an integer and it is now the constant is now assigned to it. All right. Sometimes Swift can't figure out the type of something and it'll let you know. So let's uncomment this line. I think I've mentioned this before, one way to uncomment is to press Command and the / and it removes the comments. Now check out the error, type annotation missing. Well, what is a type annotation? Let's comment that out. It says missing. When it's missing, Swift they don't know what it is. It can't tell because there's no assignment and there's no other way to know. There may be times when you don't want Swift to use a type inference because it might not be the type you want. Because you may want a double or an int, and sometimes you want to assign it. So in this case, what you do is what we call a type annotation. So you tell Swift exactly what type you want to use. So notice here we have annotated double and we have a colon and then double equals 20. Now, even though there's no decimal point, we know that it's a double because we've given a type annotation. We've told it what it is. Now here below, because we're using a decimal point, we infer that, okay, that must be a double. And then of course now these two types are the same. You can combine them and multiply them, things like that. So where do types come from? Well, Swift has built-in types that represent the basic building blocks of all programs. We've already talked about strings, we've talked about ints. They're what we call the Swift standard library. So all programming languages have a kind of basic set of features. And so aside from strings and ints, we have things like any collection, a join sequence, character view, slice, range, int64. So you'll notice that all these types begin with a capital letter, and then they use camel case for any additional word. This is important. Notice that the type is always capitalized, so keep that in mind. It says both use, so notice we talk about types beginning with a capital letter, which is different than, say, a function, variable, or a constant. So both are camel case, but types use upper camel case as opposed to lower camel case. All right, think of some types of your own and how they'd look in upper camel case, like training shoe or racing bike. All right, let's figure it out beyond the standard library. So programmers can create their own types by combining and adding types and different features from the standard library. So you can create your own, and we'll do that throughout this course. So for example, take one of our made-up types, imagine what it might be. So for example, training shoe might be an int for a size, a string for a brand name, a date for its release date, another int for its price. Type and capabilities can be grouped together in collections called frameworks or libraries. We'll talk a lot about this as we go. One important framework is the Foundation framework. So the Foundation framework has all sorts of types and a lot of additional things like dates, distances, and files on a computer. So these extra frameworks aren't automatically added. So if you want to use them, let's figure out how we do that. So to use a framework, we have to import it. We use this import keyword. So we have import foundation. So one of them is a date. So if we say let today equals date, then that's what we get. Now, so unlike strings and numbers, there's no way to create a date from a literal. Like we wouldn't be able to create a value from a literal. We have to use this method. So let's comment out the import foundation, see what happens. Oh wait, it didn't like it. It doesn't know what it is. It's confused, unresolved. All right, so it's important that we have the foundation imported. Now let's try some things. What if we say let some date equals date plus 10. Notice how what did it do? What did it do? It didn't really change anything. Let's change this. What if we add a large number like 5, 4, 3, 2, 1? Oh, all of a sudden now it changed. See that? Now it changed. What if we subtract a larger value? What if we say subtract it? Ooh, we went back in time. Pretty cool. So we have talked that every constant or variable has a type. For variables, the value can change, but the type cannot change. So types describe what a value is, what it can do, and where you can use it. And we use type checking to make sure that it's being used properly, nothing gets accidentally changed. We can use type annotation to explicitly specify what the constant or variable is. So let's check it out in the exercise. The circumference of a circle, the distance around the edge, can be found by multiplying the diameter of the circle by pi. Here's an approximate value of pi. Write a program to calculate the circumference of a circle with a diameter of 2. Create a constant to hold the diameter. What type will the constant need to be? So, for example, notice how this is a decimal point, so what type is that? It's a double. So if I say let circumference equals 2 times pi, then it's going to calculate a value like that. Now let's put the circumference, the diameter, let's put the diameter into a constant. So we say let diameter equal 2. Now what's going to happen? What do you think is going to happen when you do this? Diameter. What do you think happens? It throws an error. Why did it throw an error? Well, because notice if I press option and I click diameter, diameter is an int. It inferred that this is an int. Well, how do I fix that? Well, I can fix that by doing a couple things. One, I could actually go and I could say 2.0, and then it thinks of it that way. And notice if I press command and then I click, because it sees it as a double, right? That's one way to do it. Or what we call type annotation, we say double equals 2. And it resolves the same way. Awesome. All right, thanks for watching. Be sure to subscribe. Check out the next video.